I'm going to give you a quick tutorial about finding an equivalent score from moving from one distribution to another. Here's our question. Imagine that James takes version A of the history test. The mean was 50 with a standard deviation of 10, and James earns a 65. Okay, so then we have this distribution, a mean of 50. Standard deviation is 10, so one standard deviation above the mean would be 60. Next standard deviation above would be 70, and James is a 65. Can you see that James is 1.5 standard deviations above the mean? If he was just one standard deviation above the mean, he would have a score of 60. If he was two standard deviations above the mean, he'd have a score of 70. But he's exactly between 60 and 70. So he has 1.5 standard deviations above the mean. His z-score would be 1.5. Remember that z-score is how many standard deviations are you above the mean. So I'm not going to calculate the z-score. I figure you can look that up elsewhere, but here is his value is 65. His z-score is 1.5. He is 1.5 standard deviations above the mean. So it would be the equivalent score in this new distribution. In this new distribution, the mean is 75. To be one standard deviation above the mean would be to earn an 81. To be two standard deviations above the mean would be to earn an 87. We know that James is going to be 1.5 standard deviations above the mean in this new distribution, just like he is in the old distribution. So for version A, he will be 1.5 standard deviations above the mean. What does it mean to be 1.5 standard deviations above the mean? To be one standard deviation above the mean, we would add 6 to 75. If we're going to be 1.5 standard deviations, it would be 75 plus 6, and then half of 6 is 3. So 75 plus 6 plus 3, that comes out to be 84. And 84 is right there between 81 and 87. So for James, his score in the new distribution that is version B is going to be an 84. That is the value in this new distribution that is exactly 1.5 standard deviations above the mean. That in a nutshell is what we're doing. We're just finding if you're 1.5 standard deviations above the mean in the old distribution, then what value corresponds to being 1.5 standard deviations in the new distribution. Okay, let's look at the math for that. For version A, we took James's value of 65 and we put it into the z-score formula. 65 was the value minus 50, which was the mean, divided by 10, which is the standard deviation. That's 65 minus 50, that quantity divided by 10. 65 minus 50 gets you 15, so 15 divided by 10, and 15 divided by 10 is 1.5. For version B, now we're looking at that rightmost distribution that has a mean of 75 and a standard deviation of 6. We want to find James's equivalent score. Our formula is value is equal to the mean of the new distribution, 75, plus, and now we're going to multiply two things, the z-score. Where do we get that z-score? We just calculated it's 1.5. It's where James stands in the old distribution. So that's z-score times the standard deviation of the new distribution. So when we're calculating value, we're using the mean and standard deviation of the new distribution, and we're bringing to that formula the z-score of where James stood in the old distribution. We want to find the equivalent score. So when we do the math, the mean is 75 plus 1.5 for the prior standard deviation times 6. 75 plus, and then the 1.5 times 6 is equal to 9. So we get 75 plus 9, and that equals 84. And that's how we figured out that James had an 84. And that value of 84 is exactly 1.5 standard deviations above the mean in the new distribution, just like 65 was 1.5 standard deviations above the mean in the prior distribution. Both scores are the exact same, and that they're both exactly 1.5 standard deviations above the mean. And that's what we mean by an equivalent score. And so whether we're looking at the 65 in the old distribution or the 84 in the new distribution, their z-scores are the same. The proportion of people that they scored above is the same. Everything's the same except for the fact that we are dealing with the new distribution. And so what value corresponds to being 1.5 standard deviations above the mean in the new distribution? It's an 84.